Just a minute. I'll adjust the board. Is voice clear? Comment first. Voice is clear? If clear, I will start. First, your answer. A little later, I will keep on explaining. There is no question of asking in between. Voice fully clear? Clear. Okay. See, I told shortcut method, heading I not written here. This is shortcut method for finding slope and deflection for cantilever. But remember, shortcut method means you cannot directly go to shortcut without knowing anything. So, some concepts are required. It is not one class. Maybe I need one more class or two more classes. I will conduct systematically. Today, I will take a little more time because one day bear with me. Instead of 9, I will take little more. Okay, see, first, consider a cantilever beam AB. I told AB, never by heart left side, right side like that. Beam, what I do usually is, left side point I take A, right side B. So many times in exam, what they do is, see, they give a cantilever here. One point load they will give here. Then they will call A, B, C. Then you should write cantilever beam AC, not AB. So do not by heart names, alphabets. AB, see. Subjected to any general loading. See, this is any general loading. General loading. Here and there both. See. Some loading. See now. Draw first bending moment diagram. But before that one, remember, this is free end, this is fixed end. Here, left side is fixed, right side is free. Here, right side is fixed, left side is free. Again, do not by heart that way. You remember free end and fixed end. Okay, now, draw bending moment diagram. See, what you do is, when you draw bending moment diagram, usually in double integration method or Macaulay's method, you need sign convention. You write sagging positive. Later, in conjugate beam method also, sign is required. But moment area method, I am giving introduction to moment area method now. For moment area method, sign convention is not required. Because, see, the beam will hog. This also, beam will hog. So, elastic curve, I have shown that way. You account for sign in the elastic curve. So, do not use minus sign here. Even if you use minus sign, do not consider that sign. Some people, they take sign convention. No, confusion. I will give you easiest approach. But, see, I written the moment area theorems here. Those who are in the BSK batch, these two theorems I will prove. Not now. Because this class, I made general for everybody, shortcut method. There I will prove it. In the regular class, I will prove. Today, you believe me, as usual. Believe me only. See. Bending moment at this point 0. But need not be 0. If a couple is there, BM can be there. So I don't know. So I'll do one thing now. I'll put BMD like this so that BM can be here. Now BM here, look this side. If a couple is there, that is the BM here. If couple is not there, BM is 0. Come to fixed end. Remember, at the fixed end, there will be a vertical reaction and reacting moment. You should know that one. Here also, vertical reaction and reacting moment. So, when you come to B, look this side, 0 or couple. When you come to A, some will tell, look this side, 0. No. If you look this side, that couple will come. But you need not calculate the reactions. Remember, for cantilever, you write everything. Not required. When you want BMD, see, if it is this beam, see what I am telling now. Look always free end side. Go to free end. Look this side. Unless a couple is there, bending moment is 0. Then don't turn your head. Come to fixed end. Again look free end side. Moment of all this load about this point will give BM here. Variation. If only couple is there, rectangle. If point load is there, triangle. If UDL is there, parabola. If UL is there, parabola, 30 degree. That all will come later. So, random BMD. Here also, see. BM at A. Look this side now, free hand side. It is either 0 if there is no couple here or some couple. Come here. Look this side. Moment of all this load will give BM here. Again variation. Now, under normal case, remember I am discussing a not abnormal case. Sometimes, see in gate all, they will give a downward load here, they will give a upward load here and downward load here. Then elastic curve will have odd way. Maximum deflection may not be here. It may be somewhere else also. That's all called objective question that I will cover in the course, not here. Now, under normal loading, beam will bend like this. See, this blue color is elastic curve. Elastic curve. See now, how the beam bends. Here, this is fixed end. See, when you apply load, bending is like this. Here, this is fixed end. Bending is like this. Draw elastic curve, hogging BM will come. Okay. Now, in case this way couple of pairs sagging can come. Okay, now, leave as it is now. Don't come here now. But one important property, see, when the beam bends here, at B, there will be maximum deflection. And at B, there will be maximum slope. This all I told you in the earlier class. So, for cantilever, under normal loading, see, for cantilever, remember, under normal loading case, under normal means not perpendicular, normal means mamuli. Normal loading case, theta and y both are maximum at free end. Don't change your mind now, at free end. Whereas both theta and y equal to 0 at fixed end. Why? Because fixed end can never rotate nor move. So here theta, see I written here I written theta 0, y 0. Theta max, y max here. Here also theta max, y max free end. Theta 0, y 0, or I will put in the elastic curve once again here. Our most important is theta 0 here. Y0 I don't require. Theta 0 here. Here, theta equal to 0. Now, the most important part. When slope is 0, if you draw a tangent, tell how will be the tangent? Tell the answer. When slope is there, tangent will be inclined. When slope is 0, how is the tangent? Tell me. Common sense. 0 slope means how is the tangent? If slope is 0, how is tangent? First. If slope, see, slope is always angle measured from the original axis to the tangent. Tangent is horizontal. Or remember now, one important principle at A, if you draw a tangent here, it is 0 slope horizontal. So, I want to extend this tangent. See, this tangent at A you can draw like this any length. So, this original axis of beam itself is tangent at fixed end. So, make the next important note, very, very important for moment area. Tangent at fixed end will what? Will merge with axis of beam, or you can see TA. This is not TB. Same line I am writing. TB is somewhere here. So for some reason I want tangent to be named on both sides. Here see, tangent at B will be like this. Okay, this is tangent at B. See here, zero slope. Okay, now therefore this question, see, now this is the tangent at B. Therefore remember now, here your theta max will be theta, or I'll do one thing now, common statement, common for both. Theta max will be at free end. Therefore, for this example, theta max will be theta B, and for this example, theta max will be theta A. Tell me, fully clear? For this example, theta max is theta B. For that example, theta max is theta A, or general statement, theta maximum will be at the free end. Okay, now, where is Y maximum? Common. Under normal loading, Y maximum will also be at free end. Therefore, for this example, your Y max equal to deflection at B. For this example, your Y max equal to deflection at A. Correct? This is important. Now see. Now, time being, you leave this one. Come to moment area method. I will tell you why. See, yesterday I have given some example for you. Point load, UDL, UVL, all. I told you to get the answer. Did you get it? By Macaulay's method. Did you get the answer? Integrate 2 times, substitute boundary conditions. I told for point load, WL square by 2 slope, WL cube by 3 deflection, UDL, WL cube by etc. Did you get all that one? Or not tried? Did you try all that one or still pending? Yesterday's class I have given homework for you. You are not answering. Did you try it or still pending? Did you try it or still pending? See, I got to answer fast because this is one problem. If you are not answering, I don't know. Okay, not yet. Okay, try later. Now, there is a sequence to remember that one. I will tell you here now. All the result there, we will get it now by moment area method. Okay, 1 minute. Now come to moment area method. See, suddenly someone will tell, how you are going to moment area method without derivation. Today you believe me, derivation comes in the usual class. Okay. This is based on Moore's theorem. 2 theorems are there. One of them is called Moore's first theorem. Second is Moore's second theorem. What all I tell you should write. Moore's first theorem connects theta, rotation. Moore's second theorem gives some information for displacement. It is not deflection. It may be deflection. In cantilever, it is actually deflection. In simply-supported beam, it is not deflection. It is something else which you have to convert to deflection. Okay, start. Now, Moore's first theorem statement is the change of slope. Change of slope is today, see, today your income is 500 per day. After some time, income will change over to 1200. So change of income is 1200 minus 500. Remember, it is a relative. So the change of slope of tangents drawn to elastic curve. between any 2 points of your choice is equal to area, when you are connecting the slope, area of BM by EI diagram between those 2 points. If I want change of slope from A to B, area from A to B. If I want randomly P to Q, area between P and Q. BM by EI diagram between those 2 points is Moore's first theorem. Second theorem is a special theorem. It will tell you I am using the word vertical displacement because I am considering beams. If it is a vertical member, if it is a column, it becomes horizontal displacement. My discussion is for beams. That's why or displacement perpendicular member. The vertical displacement of any point in elastic curve, very, very important. That point should be in the elastic curve, not somewhere else. In an elastic curve, with respect to tangent drawn to elastic curve at some other points. So when you use Moore's second theorem, your point should be in the elastic curve. See, your point B is here. In the elastic curve, point B has gone here. You should not take B there. You should take B here. A will remain there only. See, and some point, random point R, I have taken here. See, some random point R I will take here. R means random point, R. Initially it is here, but see, now it is somewhere here. It has moved. So that vertical displacement of point, any point in elastic curve with respect to tangent drawn to elastic, tangent to elastic curve, drawn to elastic curve at any other point is equal to, when you apply first theorem, only area. Here, moment of the area means area multiplied by centroidal distance. Moment of the area of BM by EI diagram between those 2 points. About that point, which point? See, here, see, the vertical displacement of any point. About that point means for which point you are considering vertical displacement. So, about the first point. Now, to understand correctly, see, one simple example. You don't see here. Consider any 2 random points P and Q. See, I am highlighting P. Note, first point, very important. I used red color for that one. He is the critical point, P. Q is any other point in elastic curve. Then, from Moore's first theorem, you can do one thing. You can close your eyes and write what? Slope at the first point minus slope at the second point equal to area of BM by EI diagram between those 2 points. Clear? If I write first theorem for A and B, theta A minus theta B equal to area of the BM by EI diagram between A and B. Or if I call EF, theta E minus theta F equal to area of the BM by EI diagram between E and F. Clear? Clear or not? Clear concept? I am rubbing everything now. Then I will tell you simple way now. I will make shortcut now. Okay, now. Next. Yep, now. By second theorem, see, my first point is P. See, red color. Vertical displacement of P. It should be in elastic curve. Vertical displacement of P with respect to tangent at Q. That is, Y means vertical displacement of P, Y or delta. You can either call Y or delta, your choice. When I do problem, I may call delta because Y universally popular delta. Y of any point P with respect to some other tangent at some other point Q is moment of the area of BM by EI diagram between P and Q about P, not Q. Suppose I tell the theorem for E and F. What you have to tell? E, vertical displacement of E with respect to tangent at some other point F is equal to moment of the area of the BM by EI diagram between E and F about E. That's all. Now, this all I will remove. You go through again and again and understand. Now I will go to shortcut. See, I will go to shortcut. Can I remove all the statement now? Tell me. You can take a screenshot later and why? You can take a screenshot later and study thoroughly. Okay. Now, all I will remove and tell you the easiest way to solve the question. See, everything I will rub it now. See, even though it is a shortcut method, see, I am telling the principle. All those people who think shortcut means shortcut without any principle, they are wrong. They cannot understand anything. If you want shortcut or solve fast in examination, you should know the concept. Then the shortcut will be useful. Otherwise, there is no point in studying anything. 1 minute now. See, now I will tell you final summary of this one. Then I will go to problems. Today and tomorrow and one more class maybe. So that let it be permanent in YouTube. Okay, see. Now, come to this cantilever. Come to this cantilever. See, I will put here now. Consider the first cantilever. So, I will call this as cantilever A. This I will call cantilever B. Consider A. One is sufficient. Consider A. This is the beam. See, I already told you beam. I want elastic curve. Only elastic curve. See, I want only elastic curve. Little bigger. A and B. No, don't write B here now. See, do not name here. Name, that's very important. One important aspect, do not name the points now. Name it after deformation. This is the original position. See, elastic curve. I use blue color for elastic curve. To understand better, blue color. Right, okay. First one. See, elastic curve will be like this. Okay, random. So some little, okay. Touching that one. Okay. So I have seen some people will tell for cantilever elastic curve is it will be parallel then this way. What nonsense is this? They will tell up to some distance it will remain same. Looks so nonsense. It will start deforming right from here. Only at this point zero slope. Okay, sorry, color. Okay, now see. Ayo, slipping. Okay, no problem. Okay, elastic curve. See now. Very important. Now A will remain here only. Why? Because elastic curve point, original point tallies. And 1000 times I told, this is tangent at A, or tangent at fixed end. Don't by heart A, tangent at fixed end. Okay. And theta 0 means theta equal to 0 at fixed end. Fixed end. Okay, now the point B will be here. Now tell me, if I draw a tangent here, tangent at B, draw this way, this is the slope of the point B. Now, use first theorem. First theorem, consider the pre and B, consider the point where you want slope. Remember, in cantilever, simply support beam changes will come. For cantilever, first you make a note here. Somewhere make a big note. I am dictating here. In case of cantilever beam, the first point should be always that point where you want slope or deflection. For cantilever, see, usually competitive examination, most popular is cantilever. So in case of cantilevers, the first point should be always that point where you want slope or deflection. Clear? Where you want slope or deflection. Clear or not? Where you want slope or deflection. Okay, now I want over. I want slope at B. I want slope at B. Therefore, apply the first theorem from B to other point. Other point for cantilever is permanently fixed end. Remember, first point will keep on changing. If I want slope here, B is first point. If I want slope here, that is first point. If I want slope here, that is first point. Other point will be always fixed end. So, if you want slope at the free end, B to A, then theta B minus theta A, see, theta A equal to area of BM by EI diagram between B and A. From B to A, full area, now remember, theta A equal to 0. Therefore, directly we get theta B or theta at the free end. Therefore, to get slope at the free end, even same here also, see, consider A to B. Then what happens now? Theta A minus theta B. Theta B is 0. So I won't tell two times. Finally, I put conclusion over. You get the answer. Then, suppose I want theta somewhere here. See, any point R here, random point R. Draw a tangent. This is your theta R. If you want theta at any random point R, apply the first theorem from R, that point to fixed end, R to fixed end A. Then theta R minus theta A is 0 equal to area of BM by EI diagram between R and A. That is that point, and here also, see, here also, theta R minus theta B, R and fixed end, R and fixed end. Fully clear? Lastly, I will conclude for shortcut. In the shortcut, no theory, nothing. But people who want to understand should know all these things. Okay, now I want deflection. See, this is the deflection at B. You know it. Deflection at B. But this deflection at B is equal to displacement of B with respect to, actually this is displacement of the point B with respect to tangent at A. Oh, that itself is deflection at B. Therefore, what you do is, if you want deflection at B, free end deflection, find deflection of displacement of free end with respect to fixed end tangent, YBA. B is the first point, equal to moment of area of BM by EI diagram between B and A, very important, about B. Okay, now this YBA will be directly equal to YB. Okay, now suppose I want, see, this one, what is one? Displacement of R, once again with respect to tangent at A. That itself is deflection of R. So what you do? If you want deflection of any point R, YRA, moment of the area of the YR, area of BM by A diagram between R and A about R. If this is clear, I will give you final verdict here. I will give you final verdict so that shortcut means those who are writing competitive examination, they don't have to bother about all these things. Directly start. Is this much clear? So therefore, final conclusion for cantilever. Now onwards, I will not tell for cantilevers. To get slope theta anywhere, theorem not there. To get slope theta anywhere, use first theorem. From where to where, not required. From that point to fixed end. So, first theorem what? Theta anywhere equal to area of BM by EI diagram between what? Between that point and fixed end. Over. Chapter closed. If I want, always remember area from BM diagram between that point where you want slope up to fixed end. Over. Conclusion. Over. Now, to get deflection y at any y or some people call delta. I may write delta later because people like delta more. Y or delta anywhere. Then delta or y or delta anywhere equal to moment of area of BM by EI diagram, same way, between that point and fixed end, and very important, about that point. Crystal clear? Tell me. If crystal clear, all I will remove and start one by one example. I will write one more example here now. Okay. Now, this full I will remove. Those who are serious, study everything and understand. Those who are serious, nothing can be done for them. They cannot be repaired. Coming to a class, vanishing, again attending, then commenting. This is not clear. That so far it never happened in my class. See, now I will tell correctly here. See, cantilever A once again. Last chance for you. Cantilever A once again. See, this is B. Don't buy it. This is any point R. This is what? A. A is fixed end. Tell the answer. If I want theta B, see here now. Suppose I want theta B and deflection at B or delta B. Tell what you do. Tell me. Draw the BM diagram. Bending moment diagram. Then you should consider BMD from B to fixed end. That is, B is here, fixed end is here, full area. So, this full area considered. Full area considered. You get theta B. And if you want deflection at B or delta B, what? Same full area. Full area means full area. Same full area, but consider what? Consider moment of that area. About where? About free end, not fixed end. About free end, that is B. Okay, now, note it now. Same thing here also, see. If it is A here and B here, fixed end here, then if BMD is like this, okay, BMD. If I want theta A, then full area. Why? Free end to up to fixed end. Wherever you want slope and deflection, From there, you have to go up to fixed end. Theta A is full area. Okay. But of course, full area by EI is there, BM by EI is there. Full area considered. Okay, now, suppose I want deflection at A or delta A. That is free end deflection. Then also full area, but consider what? Consider moment about fixed end. Here also fixed end, there also a fixed end, that is A, B. Here fixed end is A. Okay, A. Over. This is to find, see, therefore, lastly, I will put a box here and dictate, right, once again. Okay, now, suppose you want one second round only. This is A, this is cantilever B. Cantilever B. Okay, now, second round. You need theta R and deflection at R. Here also, any point R. Theta R and deflection at R or delta R. Then, this is a BMD, see now. Then, this is a BMD. Then, consider area for theta at R. Consider area from R up to fixed end, this area. Don't consider, because where you want, from there go to fixed end, this area. Consider area from what? From R to fixed end. Here also, same statement here. Consider this area. And if you want deflection at R, same thing, same area, but consider not area, consider moment of the area. Moment of area about R, that point. Tell me. This is speciality of cantilever. This will not work for simply supported. This is only for cantilever. Full clear? If full clear, I will put a box in the free air and dictate something. Tell me. If full clear, then I will start. I will not tell anything further. Okay. Now see. I will non-stop talking. I will take a small break. Small break. When I come back, I will start getting all the answers. And so many tricks I will tell you. Don't worry. See. Okay, now see. Moment I am discussing about if moment area method is used. Moment area method is used. I will tell you why. Sometime very useful. Used. Then see. What I am going to tell, looking towards you and showing a box here, write everything there. Anywhere you want slope, area from that point up to fixed end. Anywhere you want deflection, area from that point up to fixed end. But remember, for slope only area, divided by EI is there. For slope only area. For deflection, moment of the area about that point. About which one? About that point. I wrote by chance about fixed end earlier. Tell me. By chance I wrote about fixed end earlier. I don't know. See, suddenly. I think I wrote about, by chance I wrote about fixed end earlier. Tell me. I don't know. Sometimes it happens in a, did I write about fixed end earlier? By chance I told earlier correctly. Tell me. Just now while concluding. By chance, did I tell about fixed end? Oh, tell me. By chance if I tell. Slip of tongue. Tell fast. I don't want such a mistake. It is a slip of tongue. I don't know your comment. Anyway, I am repairing now. See, no answer. Did I by chance tell about moment about fixed end? See, no answer. Did by chance I tell about fixed end? There is a chance that I want to tell up to fixed end, but my purpose is to tell up to fixed end. Slip up tongue maybe about. Okay, change it now. Okay. See, human being. I told earlier, moment should be. See, already I told earlier. Yes or no? This is called slip up tongue. Okay, such thing should happen to show that I am also human. See, by mistake actually I want to tell area from that point up to fixed end, about not fixed end, about that point. So I will tell once again now. Okay, now this is the final for you. Anywhere you want slope, consider area from that point, see that point up to fixed end. Anywhere you want deflection, consider area from that point up to fixed end, but consider moment about which point? Moment about, not fixed end. Moment about, slip up tongue. Moment about which point? Moment about that point. So I will tell you here now, see. A, B, any point R. If I want theta B, area from B to A. Area from B to A. If I want theta R, area from R to A. Same way here, see. If the beam is this way, A, B, same beam. Or if the beam is this way, this is A, this is B, this is any point R, random point R. Any random point R. If I want theta A, then area from here up to fixed end. If I want theta R, then area from that point up to fixed end. This area. Tell me, clear, fast. Clear or not? Area from that point up to fixed end. If you want free end slope, free end to fixed end. If you want random point slope, random point to fixed end. Now clear? If you want free end slope, free end to fixed end. If you want random point slope, that random point to fixed end. Clear or not? Free end slope if required, free end to fixed end. Ending is always fixed end. And random point slope if you want, from that random point to fixed end. You are not telling, clear or not? Clear, okay. Now, second time. Suppose you want deflection. A, B, any point R. This is for slope. This is for deflection. Here also. See, one small slip of tongue. How damaging it is. Okay, see now. Suppose you want deflection Y or delta at B. Then full area from there up to fixed end. Area to be considered area, but remember, not area, moment of the area. Moment of this area. Moment of this area about that point B. Suppose I want slope deflection Y or delta at R. Moment of this area. Moment of this area about R. Here. If I want deflection if I want deflection Y or delta at A, then full area from free end up to fixed end. This area, what do you require? Moment of this area. Moment of the area, this area, about where you want deflection, about A. Suppose I want deflection Y or delta at R, then from R up to fixed end, moment of this area. Moment of this area about fixed, about not fixed end, about R. Okay, over. Actually, I never make such mistakes. My purpose is to insist that area up to free end, up to free end, up to free end. I was thinking of that one, then I forgot that. I am telling moment, area from there up to free end. Moment also of the area from that point up to fixed end. The moment of the area from what? From that point up to fixed end. If you want slope, area from that point to fixed end. If you want deflection, moment of the area from that point up to fixed end. That up to fixed end, slip up turn, I told about fixed end, I corrected it, but about that point. See, where you want deflection, when moment comes, moment should be about the point where you want deflection. Clear? Moment, when deflection comes, that moment comes, it is about that point, about which moment should be about that point where you want deflection. Now, full clear? That earlier told, you make correction. Clear? Okay. Shall I non-stop I talk now? Shall I take some 5 minutes break? I'll take the class today at least up 10 o'clock today. Because the FPM class, I told them, today no, I told them Monday I will take extra class to balance that one. Because otherwise we can't complete. Some will tell, he is telling shortcut method and not doing anything. Okay, just 5 minutes break. Meanwhile, you go through this one. Then remember, more and more shortcuts are there. I will tell everything now. But I will tell in a correct order, not random. Have patience. See, once you study thoroughly all this, in future, cantilever will have no problem. This user. See, undo. I touched the button, somebody got hidden. I don't know what is happening here. Sridhar Murthy, what typed out by K. Oh, I don't know why it is happening. I kept it there. The moment I touch, something is happening there. Okay. For 300 seconds it told. So I will take, not 300 seconds, I will come back fast. Start. Start now. This all I'll remove and start one by one. See now, all the result I gave you yesterday for getting answer, see how fast you get it now. Within no time you get it. Now, I will make a small note for you. Small note I will give for you. Make a note. Somewhere outside I will give. Then I will start rubbing one by one. And prepare the result sheet also. Today full standard formula we will get it. And then shortcut will start. First standard result, then shortcut. I'm very sorry, I don't know why that something happened, I touched it there, it is coming hidden. Now, are you able to put the comment now? Tell me. I think it is. Okay. This is horrible. I do not know why it is happening. When I lift the mobile, I touch the hand, something comes, I will touch something, it will tell hidden. Okay. Now see, first make a note. See, make a note here. Very important note. Fully audible? Let's check it. Fully audible? Fully audible or not? Full audible means, tell me. I'll start. Okay, see, I can write up to where? Up to here, I think. Let me check, I can write up to where? Up to here I can write. Oh, why is this happening? Just a minute. Can you see this line? Oh, I can write furthermore. I can write up to here, I think. Oh, furthermore I can write. Very good. Almost up to here. Yes, okay. See, make a note. See, if there is a beam, this is only for UDL, not only for UDL and UVL, not for point load. See, if UDL is there, I should not tell this one. If intensity is W per unit length, first of all, not to be told. If the length of the UDL is, suppose say L0, I will take L0, loaded length L0. Then, right here, then the total load, see, the total load equal to W into L0. Intensity multiplied by loaded length, it will act at exact center L0 by 2, L0 by 2. Clear? Clear or not? It will act at L0 by 2, L0 by 2. Clear? Some length L0. Don't tell L. Clear or not? Okay. Now, second one. If uniformly varying load is there, see, like this. Or 1 minute now. I will put anything this way. If UVL is this way, if it is UVL, this is 0, this is maximum W per unit length intensity. Then, if the loaded length is L0, then the total load will pass through CG of the triangle. See, dotted line, dotted line, dotted line. The total load will pass CG equal to area of the triangle, equal to area of the triangle, equal to half into L0 into W. This all you know it. And CG will be this side. So this will be 1 by 3 of L0. This will be 2 by 3 of L0. Okay. Second, next, last point. If uniformly varying load is like this, for example, this way, W per unit length, this way load, see loading. Then, if the length of load is L0, resultant load will come here. Total load will act here. For loaded length L0, this is the total load. Then, see, if I write here, the total load Once again equal to area of the load diagram. Equal to what? This is not that moment area. In the moment area of the bending moment diagram. Area equal to half into L naught into W. Now, resultant will come this side. This is 1 by 3. This is 2 by 3. 2 by 3. Therefore, if I take moment about this point, your moment will be W into L naught is the load into L naught by 2. Moment about this point also equal to W into L naught is the load into L naught by 2. Here, if I take moment about this point, it will be half into L naught into W is the load into 1 by 3 of L naught. Whereas if I take moment about this point, then equal to half into L naught into W is the total load into 2 by 3 of L naught. Here, if I take moment about this point of the loading, not bending moment arm, then half into L naught into W is the total load into 2 by 3 of L naught about this point. If I take moment about this point, it will be half into L naught into W is the total load into 1 by 3 of L naught. Fully clear? First tell me. Full clear means I will go diagram now. Full clear. This point load I won't tell. Yes, okay. Now, start bending moment diagram. See, I will take left side fixed. Suppose a cantilever beam is this way, of length L. If you apply a load W at the free end, bending moment diagram will be, I told if you are bending moment diagram, look free end side, never look fixed side. Here BM is 0, here BM is W into L. This is the bending moment diagram. Same way, see, if the cantilever is this way, if the load is W here, length is L, I will give everything. The BMD will be 0 here, WL here. Okay, this is a bending moment diagram. Now, for both the diagrams, tell area equal to, for both the diagrams, area equal to half into base into height. I want that way, half into base into height. Okay, now this CG will be at 1 by 3 of L here. This will be 2 by 3 of L here. CG will be here. Whereas here, CG will be here. The CG means G. This CG will be from here 2 by 3 of L, from there 1 by 3 of L. So area is half base into height. Distance of CG is 2/3 L or 1/3 L for a triangle, depending upon which point you are doing. Tell me, full clear? Full clear means next round. Full clear. Okay. Now change it. All make a note one after other one. These, see, you should make a note one after other one. Suppose there is a cantilever beam, I am telling full UDL, subjected to UDL of W per unit length for entire length. Span is L. BMD will be here, this is a BMD, or it can be like this also. Okay. BM 0 here BM, just now I explained. How much BM here? W into L is the total load into L by 2. Into L by 2, this will be WL square by 2. And it will be a parabola, not this way parabola. The parabola will be this way. This way. Means lesser area. See, if I join by a straight line triangle, simply support beam parabola is like this. Okay, now, same way here. BMD will be this way. Here WL square by 2, parabola will be like this. Okay, now, for both the parabola, your area equal to, remember, triangle half, if it is a straight line here, half base into height. Because it is this way, tell me, area is less than triangle or more than triangle? First, common sense. Since it is this way, area will be less than triangle or more than triangle. Think a little and tell me. Will it be less than area of a triangle or more? A triangle is half base into height. Less. Now, area equal to, remember, 1/3 of base into height. This 1/3 is not CG 1/3. Area equal to 1/3 into base into height. And CG will shift this side. This is not that CG. CG for the bending moment diagram. Remember, if it is triangle, this is 2/3, this is 1/3. See here. If it is triangle, this is 2/3, this is 1/3. But now, CG will further shift this side. Remember, triangle is 1/3, not 1/3, 1/4, 1/4 of the base. This will be 3/4 of base. Here also, this will be 3/4 of base. This will be 1/4 of base. Okay, now, this also clear. Triangle, the CG from the higher side is 1/3. When this is 1/3, that becomes 2/3. Instead of 1/3, it changes to 1/4. This also I am uploading in YouTube. How this came? How this came also I am uploading. Actually simply supported. Area equal 2/3 base into height. CG at 3/8, 5/8. I already recorded it. I have not uploaded it. Okay. Now, next, I will remove this one. Remove this one now. Suppose there is a cantilever. See. Cantilever. Remember, uniformly varying load is like this. Very important. See now. I will tell you why I am telling this way. To avoid confusion. This way. Or you should tell intensity 0 at free end. Free end. And maximum at fixed end. Don't tell left and right end. See, one more case is there. I will tell you now only. It is this way. This is this way. Intensity 0 at fixed end and maximum free end. I will tell you, this is comes under regular. See, this is regular. This is special. This is special. How to remember is, remember, regular means you look at the beam, look at this beam, look at this beam. Tell me, which beam gives you frightening feeling? Suppose line diagram. Tell me, which beam gives you frightening feeling? By looking, oh, if the beam falls down, what will happen like that? Tell me, upper or lower? Which beam gives you frightening feeling? This is a crude method. If you look at this beam, which of the beam gives you, by looking only, this beam, suppose it gets cut, what I should do? It will fall on my head. See that way. You remember, which this gives you frightening feeling. See, you see here, what is this one? Suddenly get cut. He will tell, oh, comfortable. See now, this will give you comfortable feeling. This will give you somewhat frightening feeling. Do one thing, put a line diagram only. No double line. Single line is better. This will, no problem. By looking, you will tell, okay, done. Here. No, you are danger. So therefore, the frightening feeling, this is my own method. This is a special case. Now see, here, BMD will be 0 here. Here BMD is moment of all this load is, if this is W per unit length, span L, see, half into L into W is the total load into the resultant load will act here into 1/3 of L, or BM will become WL square by 6. When I take a problem later, I will directly write 0 here, half into L into W into 1/3 of L, WL square by 6. Here also same way. Here WL square by 6. And this is, I forgot, right? Oh, I forgot. UDL, you should write one thing, forgotten. Parabola of what degree? You should enter. I forgot tell you. For UDL, I forgot. You enter there. Parabola of what degree? I forgot it to tell. For UDL, you enter parabola of what degree? Forgot tell you. That area equal to 1/3 base into height. I forgot tell. For UDL, it is parabola of what degree? No, parabola of what degree? WL cube. How WL cube? How WL cube will come? WL cube will not come for UDL or UVL. Impossible. It is WL square. UDL or UVL, WL square only. How WL? If you take a section XX, there WX cube by L will come. Finally, that when you put X equal to L, L cube by L, BM will come L square only for distributed load. BM always comes L square. It cannot come L cube. And variation X cube will come, but X cube by L will be there. How? See, L into L. How L cube? UDL or UVL both are L square bending. Final answer is L square. But variation is X cube. Okay. Now, see here. That is parabola second degree. This is also a parabola. Remember. But this is, I forgot tell earlier. This is parabola of what degree? Tell me. I forgot tell. For UDL you write parabola second degree. This is what? Parabola of what degree? For UVL, parabola of what degree? For UVL, parabola of what degree? Second degree. That is for UDL. You should, I forgot tell you. Third degree. Okay. It is parabola of third degree. Now remember, area is further lesser. See, triangle 1/2 base into height. UDL parabola is 1/3 base into height. Same sequence continues. Area is 1/4 of base into height. Clear? Area is one more number. I will give one more analogy for you. 1/4 of base into height. Clear? Clear or not? Area is 1/4 of base into height, not 1/3. It is a derived formula. Area will be 1/4. Clear or not? Not 1/3. Area is 1/4. I will give a list for you. Area is 1/4. Fast. Clear? Fast tell me. Clear. Okay. Now CG. See. If it is CG will be here. CG will be here. If it is triangle, this is 1/3. If it is second degree parabola, 1/4. It is a coincidence. The CG will be, now it will be further closer, not 1/4, 1/5 of base. See here, this is 1/5 of base. 5th of base. If that is 1/5, this will be what? 4/5 of base. This will be from here 4/5 of base. 4/5 of base. Now, for this one, I will tell you, BMD will come same way. See, BMD will come same way. The BM will be half into L into W into resultant here 2/3 of L. It will be double BM. WL square by 3. This will be WL square by 3. And for this parabola problem, there is no standard area. I will tell you now area equal to 1 minute. I will tell the formula for area. I will derive it. You don't bother. I will derive and give it. But advisable not to use it. Advisable not to use it. Where is the calculator? I don't know. It's here. Equal to 1/3 half by 8 here. 1 by 8 equal to 1 by x into base into height. 1 by 8. Height is 1 by 3. Area equal to 3 by 8 of base into height. Actually, remember, nobody will tell you this one. I derived it, but advisable not to use it. I will tell you why. It is odd. Sequence is not maintained. Sequence maintained for what? That happy triangle, not for what? Danger looking triangle. And its CG will be from here to here. Advisable not remember. I will tell the CG. 1 minute. How I get you, don't bother. Deflection is 1 by 8. 3 by 8 into 1 by 3 is correct, 1 to 5. Then half into either triangle again, WS cube by WL by x square into 2. That will give you 1 by 8 minus, is that you? The deflection is 1 minute, I have to get it now. 1 by 4 into base is 1 into height is 1 by 3 into 4 by 5 is 1 by 30, 1 by 30, 1 by 4 into 1 into 1 by 6 is so much into 4 by 5, 1 by 30. 1 by 30 is half CG equal to 1 by equal to 3 by 8 base into height is 1 by 3 into x bar. X bar equal to 1 by 30 into 8 divided by 3 into 3. It will be 4 by 15. But advisable not to go for it. 4 by 15 of base. This is 4 by 15 of base. But advisable because for this one there is a special procedure is there. You can ignore this one. Still I will check it once again if you want. Later I will check it. Check martibidi. 1 by area is what? 1 by 8 area is to 3 by 8. 3 by 8 into base 1 into 1 by 3 is how much into bracket 1 minus 4 by 15 equal to correct everybody. CG is at 4 by 15. This is 11 by 15. Advisable not to go for it. But still, if you can remember the formula, this will not come in sequence. Now I will tell you some important sequence. See. Okay. Now see how to remember this CG formula. Very, very easy. See. How to remember is, see, cantilever this way. UDL, first, cantilever with the point load, cantilever with UDL, and cantilever with UVL, which is not frightening. This UVL, not this UVL, see, not this UVL, this UVL. See, BMD is linear. Okay, I put here now. BMD is linear, this way. BMD is second degree parabola. Okay, I want one thing. I'll put a neat format so that no confusion. See, cantilever one side fixed with a point load. BMD comes this way. Okay, then next I'll write here. Cantilever with the UDL. BMD comes this way. Parabola, second degree parabola. Second degree parabola. And cantilever with UVL like this. BMD comes this way. This is third degree parabola. This BM is W here. This is WL. This is small w into L square by 2. This is small w into L square by 6. Now see, area here. Here area is half into base into height. Base into height. Here area, increase the number. Instead of 1 by 2, it is area equal to 1/3 of base into height. Here area, 1 by 2 over 1 by 3 over 1/4 of base into height. See how beautifully tallying. Clear now? Area you remember triangle that will take you up to there. If you remember triangle that will take you up to there. Triangle 1 by 2 base into height. Second degree UDL parabola, not 1 by 2, 1 by 3 base into height. Uniformly varying load of this type, not that danger case, not that frightening case, regular case. 0, free and 0, fixed and maximum. 1 by 3, one more number, 1/4. This clear? Clear or not? Clear. Okay, now CG also matches. CG is from here will be 1/3. CG from here is 1/4. 2 becomes 3. 3 becomes 4. Tell me, CG here from this side. But when you want moment about this point. And tell me, see, 1 by 2 area, CG 1 by 3. 1 by 3 area, CG 1 by 4. 1 by 4 area, CG how much? 1 by CG, 1 by 5. Okay. 1 by 5 of base. 1 by 5 of base. Of base. Of base. Okay, now, but we want moment about this point. So, if this is 1/3, this will be 2/3. And that you get later. See, you remember this one. From the higher side you remember. Smaller distance. 1 by 3 means 2 by 3. 1 by 4 means 3 by 4. 1 by 5 means 4 by 5. Clear? Because when you apply moment area method, we want moment about free end. So when this is 1 by 3, this is 2 by 3. When this is 1 by 4, this is 3 by 4. When it is 1 by 5, this is 3 by 5. Clear? Fast. If clear, I will go for next. And one more thing is there, forgotten. See, one more thing before that one. If there is a couple applied M here, see now, couple applied M, BMD is like this, M. Area equal to base into height. Simply base into height or 1 by 1. CG is at 1 by 2. Correct? See, how beautifully tallying. Couple means rectangle. Area 1 by 1. CG 1 by 2. Triangle. Area 1 by 2. CG 1 by 3. Second degree parabola. Area 1 by 3. CG 1 by 4. Then this one. Third degree parabola. For this triangle. Not this triangle. Not for other one. That is special. Area 1 by 4. CG 1 by 5. This sequence. Fortunately it comes. There is a reason why it came. This is also clear? Okay. Now, I will go for maximum slope and deflection. Standard cases, I will finish. See, by chance, those who are writing competitive examination, if they get confusion, formula, they sometime I will tell you, some people in the YouTube you can see, easy trick to remember. They will tell you 1, 2, 3, 4, 5, 6, 7, 8. All this remember, they will give a link for you. Then if you want this one, you have to remember all the sequence. One, see, that is horrible. If you want to remember this one, you have to come in a sequence. It is not advisable. If you remember the formula, well and good. After practicing, you can remember. But in case you don't remember, take a rough sheet and write the expression over. See, take a rough sheet, write expression. See now, this also I will remove now. Okay, now I am going to put a standard formula here now. See, correctly see. Cantilever with one couple at free end. Couple at free end. Free end. I want couple M at free end. Span L. Span L. I want theta max and Y max. Y max or delta max. Okay, start. Couple at free end means this way. Couple at free end M. See, I will put here now. Consider the beam. Couple M at the free end. Span is L. Bending moment diagram. Here BM is M. Everywhere you see BM is M. It is a rectangle M. This is the CG. Tell the answer. Now, theta everywhere. theta max is theta at free end. Free end. Deflection maximum is deflection at free end. Deflection of delta at free end. Tell the answer. Theta at free end B. Answer. Area from here to here. I won't write now. You should write. Where you want slope, area moment first, area from free that point up to free end equal to L into M by EI. Theta. And deflection at free end. I'll highlight here now. Deflection at free end equal to. See, you should write. Theta B is what? Theta B is area of BM by EI diagram between what? Between or from B up to A. Up to A. A means fixed end. Here. YB is what? Moment of, I'll put here, YB. YB is moment of, okay, moment of area of BM by EI diagram from where? From the point B up to A, about B, about where you want deflection. Tell the answer. Equal to area L into M divided by EI. EI last. L into M is the area. Moment about this point into L center into L by 2 divided by EI. So this will come ML square by 2EI. So if I enter there, theta is ML by EI, deflection is ML square by 2EI. I will give one more hint later. Now, second one, concentrated or point load at free end. At free end. That is, sketch is like this. See, anywhere fixed end, W span is L. See now, start. Here only right now. Point load W at free end. Draw the bending moment diagram. You write once again. 0 here, WL here. WL. Joined by a triangle. Now, area equal to half into L into WL by EI or equal to WL square. Some people call it instead of W, they use PL square. W, capital W, WL square by what? 2EI. Deflection equal to moment of this area half into L into WL is the total load into moment about this point. CG is here. This is 1 by 3. This is 2 by 3. See, you should make it. This is 1 by 3 from here into 2 by 3 of L or 2 will cancel WL cube by 3EI. So here slope equal to W into L square by 2EI. Some people tell deflection equal to W into L cube by 3EI. Next, third case, UDL over entire span. Entire span. You make a neat fair copy later. In a drawing sheet, write it. Of intensity W per unit length span L. Okay, start here. New. BMD will be parabola. Okay, parabola. Second degree parabola. Second degree. This is W into L is the total load into L by 2. I already explained WL square by 2 is the bending moment. Start. Area. Now area is not half base into height. For this parabola, area equal to 1/3 of base L into height is WL square by what? 2 divided by EI. If I simplify, this will become WL cube by 6EI. Oh, this is small w into L cube by 6EI. Deflection. Moment of the area about B. Area, how much? 1/3 into L into WL square by 2 is the total area. I told you this is 1 by 4. If that is 1 by 4, this is 3 by 4. Triangle is 1 by 3, 2 by 3. 1 by 4 is moment about this point. 3 by 4 of L. Now WL power 4 by 3 cancels. Na currently N2 by EI. WL power 4 by 8 EI. Lastly, fourth one, uniformly varying load, very important, zero intensity at free end, and maximum intensity at fixed end. That is, cantilever is like this, not that frightening cantilever. This is W per unit length span L. Okay, BM diagram. Start. BM 0 here. See. You write once again this way. W8 length. Bending moment 0 here. Here. Bending moment equal to total load half into L into W into 1 farad of L. I already explained that will come WL square by 6 I told. And parabola is parabola of third degree parabola. For this one, area is triangle 1 by 2, UDL parabola 1 by 3, this is 1 by 4, and CG is at triangle 1 by 3, rectangle 1 by 2, triangle 1 by 3, usual parabola 1 by 4, this is 1 by 5. Okay, start. Area 1 by 4 into L into WL square by what? 6 equal to R 24. WL cube by L cube by 24 EI. See, maximum slope WL cube by 24 EI, and maximum deflection. Same area. What is the area? Half into L into W is the total area equal to 1 by 4 into L into WL square by 6 is the area into its CG from here. This is 1/5 means into 4 by 5 of L. 4 will cancel. RI the 30. It will come WL power 4 by 30 EI. WL power 4 by 30 EI. Okay, now all this clear, tell me. All this clear means I will go to special case then. See, some people will tell 1 by 1, 1 by 2, 1 by 2, 1 by 3, 1 by 6, 1 by, some will tell you, you don't know. There are people who will tell, see, multiply 2 with 1, 2 into 3 is 6. Then what they will do? How to get 8? Then they will tell, they will tell 2 into 1, 2 into 3, 2 becomes 3, okay, 3 into 2, 6, 8 how they will get? That then if this question comes, you have to start from here. Horrible. That is called height of foolishness. Telling, linking this way. I feel very bad. If you want this, suppose you want this answer, what you have to do? If suppose, see, I will put dividing lines here. Suppose you want this answer, then according to them, you have to write this one, bring it here, apply the trick. Horrible trick. Some person long back told, see, I don't know, bending moment is 5 by 384. He told 4 and 3, 4 plus 3 how much? 4 plus 3 is 7. 7 into 8, he told 56. What is that horrible mathematics? That is very bad. Okay. Now, so far, everything clear means tell me, I will go to special case. This is fifth one, special case of UVL. What? 0 at fixed end and maximum at free end. That is special case of cantilever. Or you tell, when you look, it becomes frightening for you. W per unit length, L. I want theta max, Y max. Upper side, tell me, full clear? I am not seeing your comment so far. Upper side, full clear? Okay, now, see, cut. In that case, the triangle, now BMD will come like this. This I told WL square by 3. Tell me, if I want area, tell what is formula I told? I told formula, forgot the formula. I derived, I told and forgot it. What is formula I told? This is special parabola. See, no, not this way. This way. That is abnormal case. This is not a sequence case. It is a special case. Or when you look, frightening case, sequence is not maintained. Area, what number I told? I forgot. Area what? 3 by 8. Okay. Area is 3 by 8 of base. What is the base? Base is L. Height is WL square by 3 or equal to 3 cancels. Slope becomes WL cube by 8 EI. See. WL cube by 8 EI. Okay. Now, deflection. Same area into CG. I told some distance here. How much I told? Some, I don't remember. CG distance I told how much? I derived it. See, I got it by derivation. But who remembers? Otherwise, I will derive once again. Not a big issue. 4 by 15. Okay. This is 4 by 15 means, how much this one? This is 11 by 15 into 11 by 15. Tell the answer. 11 by 15 into 1 by 8. Into of L. 11 by number. 11 by number. 11 by number. 11 by 15 into 1 by 8. Number 11 by. This is a special case. I will give you some extra hint. I will give you. Maybe after taking one more small break. I want some extra information. I will give everything today. 11 by 120. It will come 11 by 120 WL cube by EI. 11 by 120 WL cube by EI. Okay. Now, I told you this is standard. This is standard. This is standard. This is standard. If any of this you require in a competitive examination, do not use that nonsense. What? 1, 2, 2 here, 2 here, after 2, 3. 3 into 2, 6. They will tell 6, how they will make 8, I don't know. I don't know how they will make 6, 8 then. They may tell, I don't know what they will tell. They will tell 2, 3, 8. 2, 3, 8, 30. 1, 2, 6, 24. That is called horrible. So, see, there are sometimes, some of those chart, you do one thing. In YouTube, you go to deflection. There are some charts given. This is the chart given. You can see views in lakhs there. They will tell trick to find deflection. They will tell same thing. 1, 2, 2, 3, 6, 8. Something they will tell linking. That is called horrible. It is against the structural theory. That, see, I told triangle CG 1 by 3, parabola CG 1 by 4, that cubic curve becomes 1 by 5 for regular cantilever. That got reason. Okay, you can remember. But remembering this number by a sequence, if you want this answer, you have to start from here. This is horrible. Now, suppose you write an exam. If this case, any of the case comes, do you have to, if you remember well and good, see, I will tell you without looking. Couple, ML by EI, slope, look there. Because I got a grip, slope, ML by EI, deflection, ML square by 2 EI. For point load, W or P, sometimes people call it P, W or P. WL slope, WL square by 2 EI. EI I won't tell now. Deflection, WL cube by 3. W is the point load. UDL intensity W. Slope, WL cube by 6. Deflection, WL power 4 by 8. Uniformly varying load of 0 at the free end, fixed end maximum. Slope, again I derived. See, again I derived. See now, I derived once again. WL cube by 24. Correct? 24. And deflection into 4 by 5. Naku 6 WL power 4 by 30 EI. This I can't remember. Okay, now leave this case. If any of this case, if you remember, okay. And now I will tell you L square, L cube, L power 4, L cube, L power 4. How to remember that also I will tell you. If you make one small mistake there, problem gone. Okay, now, 1 minute. If any of the case comes, if you remember, well and good. If you cannot remember, suppose I want this answer. Do you have to go all round or take a rough sheet, draw the triangle, draw the BMD area, triangle 1 by 2, parabola 1 by 3, 1 by 4 into base is L, height is WL square by 6 or 24. When you want deflection into, this is 1 by 5 into 4 by 5, 4 R 1 by 30. Tell me, this basic derivation, is the derive, if confusion comes, tell me, is it better to by heart all these or use some nonsense sequence or take a paper and derive? What is better? Take a small paper and derive or print mistake. Nothing to worry. When I come second round, I will tell you. I thought deep slope. Okay. Such mistake I won't make. Okay. Print mistake. Anyway, I told you I am explaining how to decide power of L. Number I told you. How to decide power of L. I will explain for you now. I will explain correctly, don't worry. It is better to take a rough sheet and derive. 1 minute. Now, last make a note. Suppose this special case comes. What? The frightening cantilever. This case comes. Then, to get slope and deflection, that area, area 3 by 8, 3 by 8. CG, adeno 5 by 14. That way, horrible. What? And you can't by heart this way. And those who got a capacity to by heart, they will do anything. What you can do is, or for this one, there is an alternate vyavastha. Alternate. See, if this case comes, what you do is, see, you take full rectangle as a downward load and then this much you subtract upward load. Clear now? Is this downward load is this downward minus this, see, this is positive, you should take negative here. Clear now? If that special cantilever comes, what you do is, you take a rectangle means UDL, W here. This is clear? Make a note. Clear or not? You replace it by a rectangle full, subtract that triangle. This is clear? This load equal to this load minus this load. Clear? Now do one thing. Very easily you can get, see here. For this one, slope equal to 1 by 6. For this one, slope equal to 1 by 24. So, for this one, real slope equal to full 1 by 6 minus 1 by 24. Calculate. WL cube I will tell you, don't worry. WL cube I will tell you. This is 1 by 6 slope. See, UDL is 1 by 6. This is 1 by 24. 1 by 6 minus 1 by 24. If this case comes, you UDL minus this will give this one. See, if special case comes, it is equal to UDL case minus regular case. Answer, 1 by 8. Correct? 1 by 8. Oh, correct. Yes. So you can tell this I can get from subtracting this from UDL, full UDL, subtract this one, you get the answer. Deflection, see there. UDL deflection is what? 1 by 8. ಇಲ್ಲಿ ನೋಡಿ. Triangle deflection is 1 by 30. Now calculate 1 by 8 minus 1 by 30. From this one, subtract this one, you get this one. Answer. 1 by 8 minus 1 by 30. Instead of remembering horrible that 4 by 15, 5 by 15, etc. confusion, this minus this will give this one. How much? 11 by 120. Now, so all these cases clear? Tell me. All these cases clear means I will come back and tell you how you know L power 1, L power 2, L power 2, L power 3, why L power 3, I will tell you why L power 1, why L power 2, why L power 2, why L power 3. For all these cases, why slope is L power 3. For all these cases, why slope is L power 3 and deflection is L power 4. I will tell you, if you know that one, you don't have to worry then. Power confusion will not come. You want to know or not? Sometime they will put the correct number, then get confusion. L or L square or L cube or L power 4. Do you want to know or not? Do you want to know or not? Why? Yes, I will tell you. But non-stop talking. Again, 5 minutes break. Okay, no problem. 5 minutes break I need because talking too much. Bear with me for 5 minutes. Okay, just 5 minutes. I will tell you correctly how you decide. Lastly, I will not look there. I will look towards you and tell all the result once again. At that time, I will have my calculator ready with me. Why? Because where I cannot by heart, I will do something like this. See, first of all, I don't require all this. This everything comes by imagination. Okay, just 5 minutes. Wait for 5 minutes only. Don't leave the class. Bear with me for another 5 minutes more. Because non-stop talking of this type gives you a lot of strain. Remember, real shortcut is still to come. I will tell you what. See, real shortcut means sometime they will give you load here, find deflection here, or load here, find deflection here, UDL here, find deflection there, or UDL here, find deflection here. For objective question, everything I will make easier for cantilever. For cantilever, everything I will make so easy that people will tell, oh, this way if I learn for competitive examination, I can never make mistake for cantilever deflection. Simply supported, extra class required. Okay, but 1 minute. Right now cantilever. My announcement is cantilever. Okay, now, see, yesterday I told you answer for Macaulay's method. Did I tell same answer yesterday? Tell me. Did I tell same answer yesterday? Tell yes or no. Did I tell the same answer yesterday also? Yesterday I told section XX bending moment. I told, oh yes, now you can work out. See, tell me, which is better? Moment area better or Macaulay better for cantilever? For cantilever, moment area better or Macaulay better? Undoubtedly, for cantilever, moment area is the best one. Okay, 5 minutes. I'll come back. Okay, I will start now. Final conclusion of this class. I have to slightly clean the board. Okay, I will clean here. Okay, will do. See, as I told you, see, I don't go for show off or what. Talk in simple way, not stylish way, and these small things I don't bother. Sometimes people bother so much about unnecessary things, but subject matter nothing. Okay, see, now one small information for you. See, first for bending moment, I should not tell. See, couple bending moment will be always F into L. Yes or no? Bending moment or like kilonewton meter. For example, it can be anything. It can be Newton meter also. Kilonewton meter is the ideal example. Or dimensionally F into L. Tell yes or no. Bending moment is F into L. Force into distance. You tell yes. Okay. Now, see. If couple M comes, then bending moment is M only. Why? Because couple is already kilonewton meter. Therefore, only M into L. L will not come for couple. Why? Couple means already moment. So, for bending moment for couple, L will not come. In case one L comes in the equation, it will come in denominator, into X will come. Later when you put X in terms of L, L will cancel. So final answer for couple bending moment is only M. Okay. Point load, W or P, it will be in kilonewton. Therefore, to get kilonewton meter, what? W into L will come. L power 1. Clear? For point load for bending moment, load into distance. L power 1 will come. See, free and cantilever, bending moment, WL. Simply support beam, WL by 4, etc. Fixed end moment, WL by 8, etc. etc. W 3 by what? Sometimes you get 11, 3, just better. WL will come. Okay, now come to UDL or UVL or in general distributed load. See, irrespective of UDL or UVL, W will be in kilonewton per meter. Tell yes or no. If it is UDL, constant. If it is UVL, varying. But even then, distributed load means it will be always force per unit length. Tell yes or no. Like kilonewton per meter. Therefore, for the bending moment to come in force into L, then this is F by L. Tell me, this is, see, for bending moment, we want F into L. So, intensity is what? F by L. To make it FL, tell what you require here. What you require here? L power. What you require? L power. UDL or UVL. All these comes under distributed load. All these comes under distributed. Everywhere UDL or UVL, variation is parabola, cubic parabola. But final answer same. L square should come. Like see, cantilever bending moment, WL square by 2. Simply support bending moment for UDL, full span, WL square by 8. Fixed end moment, WL square by 12. Remember, WL square by 12. That way it will come. Clear now? And so this is for bending moment. So I will tell here, just to understand here, maximum bending moment M for this case is M maximum. For this one, your M maximum is WL square by 2. For this one, your M maximum is WL square by 6. For this one, your M maximum is WL square by 3. See, everywhere, whenever W per unit length is there, WL square should come. Okay. This is for bending moment. Now, this all are knowing. Come to slope or deflection. Slope means theta, deflection is y. y or delta, whatever you want. Okay, see now, what happens? You know that slope is always angular, yes or no? It is angular. Deflection is linear. Therefore, here L power 0 should come, or L will not come. Will not come in the final answer. Here L power what? Here L power 1 will come. Like what? Theta c comes in radians. Radian means there is no linear, no force, no linear. No linear. Here linear means what? Like meter, millimeter, etc. L power 1. So your slope answer should be finally what? Unitless. Slope is unitless as far as load and spanner, as long as load and distance is concerned. Load and distance concerned. When load and distance considered, theta is always unitless and deflection y or delta will be always linear. Linear, like millimeter, meter, etc. This also clear? Deflection will come in meter, millimeter or linear. L power 1 should come. Here L power 1 should come. Here L power 0 should come, or L should not come. Tell me. This is clear means I will tell you next step. Okay, now see. You know that irrespective of slope or deflection, we always get what? We always get something divided by what? EI. Your theta or y or deflection delta always comes something divided by EI. Tell yes or no. Fast tell me. Something divided by EI. Tell yes or no. Fast. Slope or deflection always comes something divided by EI. Okay. Now, when something by EI comes, you know one thing. EI is always FL square. Example, kilonewton meter square. Why? Because E is force per distance square, I is L power 4. Therefore, your EI will be always force into distance square. Clear? EI is always force into distance square, like kilonewton meter square, Newton millimeter square, etc. EI should be always force into distance square. Tell yes or no. Irrespective of slope or deflection, EI is always force into distance square or force into distance square. First tell me. That clear is important. Where is the mobile? Where here. I'm afraid to put the chart in the pocket, because if I use in the pocket, suddenly what happens is somebody will get removed from the group. Clear? Okay. Now, see correctly here. Force EI is always, I told repeatedly, when you find slope or deflection y or delta, denominator is always FL square or force into distance square. Therefore, for cup, and remember, slope should be always unitless. Deflection should be always linear. Deflection should be always what? Deflection should be always linear. Correct? Now tell me. When you go for couple, see correctly now. See there later. This much I told you, sufficient. See. Now, when you consider a couple M, M is always kilonewton meter. Tell yes or no. M is always force into distance. Tell yes or no. Couple means force into distance. But yes required to confirm. Force into distance. Now tell me. Couple is always force into distance. See. Therefore, for slope, what? You always want what? I told you, for slope and deflection. See, denominator is always EI. EI is always what? Force into distance square. I am telling third time now. EI is always force into distance square. So, to get slope unitless and deflection linear, tell me, this is force into distance square. Numerator should also be force into distance square. Yes or no? So that this is force into distance square. To get unitless, no unit for slope, linear will not come for slope, only radian will come. Numerator should be what? Force into distance square. Couple is already force into distance. To make this force into distance with the force in distance square unitless, L will come only once. See, M is kilonewton meter into meter, kilonewton meter square by kilonewton meter square. Slope becomes unitless. Clear or not? Fast tell me. This all make a note. Clear. Now, deflection. Denominator is what? Kilonewton meter square. To get linear, tell me numerator should be. To get linear, tell me. Deflection. This is what? I will tell you kilonewton is better. See, kilonewton meter square is denominator. See, slope. Denominator is always kilonewton meter square. Actually, it can be any unit to understand kilometer square. Here, for couple, to get same unit here, couple is kilonewton meter into meter required. Here, tell me, for couple is already kilonewton meter. Kilonewton meter, see, we want this answer to be in meter. Denominator is kilonewton meter square. Numerator should be what? Kilonewton meter cube. Why? So that kilonewton meter cube by kilonewton meter square will give what? Will give what? Will give, or you can remember one thing. What? For slope, numerator should be always kilonewton meter square. So that denominator kilonewton meter square will make unitless. And for deflection, numerator should be always kilonewton meter cube. So that when you divide by EI, kilonewton meter square, you get in linear meter or millimeter. Tell me. This is already kilonewton meter into 1 meter will make kn meter square. Here, M is kilonewton meter. Kilonewton meter to make kilonewton meter cube for deflection. What you require? Tell me. To M is in kilonewton meter. I want kilonewton meter cube. What you require? L power. What you require? L power. For slope I want L power 1. So that kilonewton meter into meter, kilonewton meter square by kn meter square cancels. You need kilonewton meter into meter square will make kilonewton meter cube. Kilonewton meter cube by kilonewton meter square will give meter. Okay, now point load, tell me. Load is in kilonewton. Point load. Now you should write yourself only. You should write yourself only now. What all I am telling, right? Point load is already in kilonewton. I told you, when you want slope, numerator should be kilonewton meter square. And when you want deflection, numerator should be kilonewton meter cube. So that when you divide both by kilonewton meter square, slope becomes unitless, deflection becomes meter or millimeter. Tell the answer. Only kilonewton. To make kilonewton meter square, tell what? For slope, you need L power. What? For slope, you need L power 2. For deflection, load is in kilonewton. To get kilonewton meter cube, you require L power. L power. But don't buy out this way. L square, L cube. Remaining all L cube, L power 4. That's the crude method. L cube. Okay. Fully clear for couple and point load. Fully clear for couple and point load. Fully clear. Couple and point load clear. Now, for UDL or UVL, your W is in, see, for all these, W is in kilonewton per meter. Kilonewton per meter. To make kilonewton meter square for slope, what do you require? Tell me. Numerator. Kilonewton per meter is there. To make that kilonewton per meter for slope, kilonewton meter square, what do you require? Meter cube you require. And deflection. Kilonewton per meter is W. To make it kilonewton meter cube, kilonewton meter, to make kilonewton per meter, to make kilonewton meter cube, you require power 4. Full clear? Tell first. Full clear. Full clear or not? Example all tomorrow you will do it. Tomorrow only 1.5 hour class. I can't cancel FPM class tomorrow. Tomorrow onwards 1.5 hour class. Okay, now I will tell you to get confidence. See, I will take my calculator if requirement is there. I never believe in by hearting. I will give full summary today. Cantilever, slope, maximum at free end. Deflection, maximum at free end. If you want slope anywhere for a cantilever, consider the area of BMD from there up to free fixed end. If you want deflection anywhere for cantilever, consider the area of the BMD from where you want deflection up to fixed end. It's moment about where you want deflection. Moment about where you want deflection. Now, couple M, BMD, rectangle M, point load W, BMD, 0 free end, WL fixed end. UDL, BMD, 0 free end, WL square by 2 fixed end. Uniformly varying load for fixed end maximum intensity, free end 0, 0 at free end, WL square by 6. Other special case, WL square by 3. Area for rectangle, half base into height. Triangle, 1/3 base into height. UDL parabola, 1/4 base into height. And then a cubic parabola for usual triangle. I told not a special case. 1/4 base into height. CG, rectangle, 1/2 of L. Then triangle, 1/3 of L from the maximum side. But you require other distance actually. This is 1/3, it becomes 2/3. Parabola second degree, not 1/3, 1/4. Parabola third degree, 1/5. That other case, I don't know. Leave it. I have derived once again. You know it. Then, slope for cantilever, couple at the free end. Slope, ML by EI. All I am telling maximum. Deflection, ML square by 2EI. For point load, W or P, WL square by 2EI slope, WL cube by 3EI. I can see myself the diagram. I am not by hearting. I can see a diagram here. Half into base in W into 2/3. 2 cancels. I am not by hearting. I never by heart first of all. Slope WL square or PL square by 2EI. PL square now. For couple, slope ML, deflection ML square. For point load, slope W or PL square, deflection L cube. Slope is 1/2, deflection 1/3. UDL, UVL of any type. Slope W into L cube, deflection W into L power 4. For UDL, slope 1/6, deflection 1/8. 1 by 6 of WL cube, 1 by 8 of WL power 4. You that can't this way uniformly varying load. Max regular one. Slope W see WL cube by 24 deflection. WL cube by 24 deflection. WL power 4 by 30. And the special case, if you remember, okay, I can't remember. You can remember that value, or UDL minus regular UVL. UDL slope is 1 by 8. UDL slope is 1 by 6. Other UVL slope is 1 by what? 1 by 24. It will give you 1 by 8. And deflection. UDL deflection is 1 by 8. That special other deflection is 1 by 30. 11 by 120 WL power 4. These are the standard pattern for remembering. If you by heart, okay, or anywhere if you got problem, you can always take a rough sheet and get it. Now tomorrow you will be knowing see, some will tell, sir, these all we can by heart, sir. Yes, correct. Tomorrow I will tell you, you can by heart so many examination. They will ask you WL, what is the deflection here? What is the deflection here? For me, it won't take much time. I can give within 10-15 seconds. No, my capacity does not count here. Here, your understanding counts. Here, I will tell 2-3 alternatives are here now. There are 2-3 alternatives. Everything I will tell tomorrow. Or, who knows, UDL can be only up to here. Or, UDL can be here. Or, uniformly varying load can be up to here. Exam they give. Or, instead of couple here, they can give couple here. Nothing to panic. Go through my class thoroughly, today's class, tomorrow's class, and most probably one more class Tuesday. You will be master in deflection. You can teach others who are struggling. Hey, don't struggle. Come here. You should tell. I will tell you. Then you will tell where you learned. Then if you feel like tell my name, this person taught me. If at all you won't tell, or ego question comes, don't tell. You tell, I only learned. Okay, well and do. Finally, what happens? Knowledge has to spread. Okay. Now, tomorrow, same time, 7:30 I will start. I will do all this application, and then I will tell shortcut also for everything. But remember, these results are required sometimes. Sometimes not required. I will give, suppose this question, see this question. You can do this one in 3 different ways. I will convince everything for you if you are serious, so that correctly you'll understand everything. Now, everything told today, fully clear? Everything told today, is it fully clear? What all told today? Fully clear? Okay. So, we will meet tomorrow at 7:30. Tomorrow restricted time, 7:30 to 9 only. One more class will be there. Coming Tuesday, I will close this one. Then for the BSK batch, I will tell how the moment area theory actually came. I will prove that one. Okay. Today you believe me. You can always believe me. You know it. Okay. Thank you. And all those who are newcomers tomorrow, if anybody is there, I will tell them, go through everything, not suddenly come somewhere and tell, this is not explaining. No problem. Let them complain. You cannot make everybody happy in this world. Okay.